Hi, it's me, Tim Dodd, the Everyday Astronaut. Welcome to my live coverage of Delta IV Heavy. This is actually one of my favorite rockets that's currently flying. Now, granted, I have a close personal connection to it because it is the first launch that I actually caught with my own eyeballs. Like, I had been to launches before I saw a Delta IV Heavy launch, but they're always like cloudy or so overcast, even though I was like 3 miles away, 5 kilometers away one time from a Delta II. Couldn't see it through the fog, which is crazy. That sounds familiar. But yeah, so I have just close personal. I just love the Delta IV Heavy. I think it's super cool and looks like everything's actually green for today's launch. So let's go ahead and run you guys through the pre-launch preview so you know what to expect on today's launch. Now, of course, anytime you guys have any questions about upcoming rocket launches, anytime you see that there's a rocket launch coming up, and you're like, I wonder where this is launching or how much it's doing or when it's like any questions that you guys have, which I see often still online, don't forget you can just go to everydayastronaut.com and you can click on pre-launch previews. Now give me 1 second here because I realized I left this up. Okay, here we go. Pre-launch previews. So yeah, Everyday Astronaut, click on the upcoming launches and you'll see a list of upcoming launches. Today's launch, this is the NROL 82 on a Delta IV Heavy. So this is scheduled, time is subject to change, but it's actually looking good right now. We are still green, as they say, for weather and the vehicle. And that's looking like it's going to be taking off here in about 20 or 32 minutes, as you can tell. So that's 1:47 Pacific time, which is where it's taking off from. It's taking off, we'll get to that in a second, or 2:47 UTC. So the mission name, this is NROL, which is a National Reconnaissance Office launch. So this is NROL 82. The launch provider who is launching this rocket, who's the UPS or the FedEx or the, whatever, insert name there of, like of your shipping carrier. The person delivering this payload, the people delivering this payload is United Launch Alliance, ULA. Of course, one of the most trusted launch providers and tried and true. The customer who's paying for this, so the person that wants their package delivered, is, of course, the National Reconnaissance Office, the NRO. The rocket today is the Delta IV Heavy. This is the largest operational flying rocket. I mean, it's the exact same height as a Falcon 9, but each core, instead of being 3.7 meters wide, is 5 meters wide. So it's substantially larger than a Falcon Heavy. Actually, you can see my orange one there. It's larger than a Falcon Heavy. These are not to scale. This and this is not to scale. Yeah, it is the largest operational flying rocket. So that's a fun little thing to keep in mind. It's taking off today from so this is one of my favorite rockets, but it's also one of my favorite launch pads. Slick 6 out in Vandenberg has some of the coolest history in the world. I mean, it's just, at one point they're going to be launching a space shuttle from there. And when you see pictures of that, I'll show you that in a little bit. When you see pictures of a space shuttle in the mountains of Vandenberg Air Force Base on the west coast of the United States, it looks, I don't know, it just looks so like 80s and cool and like it's not supposed to have happened. Well, it didn't happen, and it should have happened, but there was no way it was ever going to happen. I don't know. It's hard to explain. Like, it's a little bit of a shame, but it looks really pretty. That's the point of that. The payload mass of this is unknown because this is basically a spy satellite. Where is the satellite going? We don't really know. Will they be attempting to recover the first stage? No, this is not a capability of ULA. Where will the first stage land? It will crash into the Pacific Ocean. And there are 3 cores that will all be doing that. Will they be attempting to recover the fairings? No, this is also not a capability of ULA. So are these fairings new? Of course. Yes, they are. The weather is currently 40% go for launch, and the conditions are windy. And that is actually a fairly big concern with the Delta IV Heavy because it's certain wind directions. It's more prone to having scrubs for ground level winds because it's so the broadside of it. Look at how wide it is. It's like a sailboat on the side. So certain winds can really have a lot of influence on it right at the launch pad. So depending on the wind direction, if it's coming straight on, it's more like a normal single core rocket where it's, has a certain threshold. But from the other direction, 90 degrees from that, it has like 3 times the surface area. So it's 3 times more likely to be scrubbed because of ground winds. So that's probably one of the things that they're paying attention to today is the winds. This will be the 143rd mission for ULA. That's a lot. The 13th mission of a Delta IV Heavy. This thing does not fly very often. It's the 33rd orbital launch attempt of 2021. We're flying a lot this year. This will be the 31st mission for the NRO, the 90th mission for the United States national security. So, of course, if you guys want to know more about this mission, kind of get more of a rundown on what all this stuff means and what little things we actually know about this particular launch, because there's not actually a lot that we know about the mission itself. But, of course, we know a decent amount about, the Delta IV Heavy. Of course, it's a pretty well-known, well-published rocket. And it uses, of course, the world's most, or one of the world, it's up there. I don't want to say the most because I don't want to pigeonhole myself in case I'm slightly off. But and of course, one of my favorite things about it too is it does use the RL-10B2, which is an RL-10 rocket engine for the upper stage that has an extending bell nozzle extension. So the bell nozzle extension is huge. This is like stupid big bell nozzle, and in order to fit it inside of a pretty standard size inner stage without just making the inner stage crazy long, they do actually make it so it extends, kind of like those travel cups. Have you guys ever seen those like camping cups that like they go and they like pop out and they get bigger? It's kind of like that, but like one section of it, and then that actually allows it to get the expansion necessary to be really efficient in a vacuum. Super cool. Conditions are still good as of right now. I like seeing that. Sweet. Launch officer says reports conditions are go for liftoff today. Yes. So yeah, if you guys want to learn more about the Delta IV Heavy, about this particular mission, which again, I just apologize, we don't have a ton of information on this mission, but go ahead and check out this article. This one was written today by Austin DeSisto, so everyone say thank you to Austin. How are you guys? I hope everyone is ready for hopefully a launch. There's actually a lot going on right now. There's this launch, which to me is obviously an orbital launch is obviously really exciting. There's also a Starship SN-15 is looking to do a static fire here relatively soon. So you guys might need to be pulling up multiple screens if you want in on all of the spaceflight action today. Of course, I will not be covering that. I kind of stopped covering the static fires for Starship. I mean, yes, they're still important. There's other people covering them, of course. Don't forget, Lab Padre and NSF normally try to cover those events. But personally, to me, there's better use of my time. I was really excited, as you guys know, to finally get a scripted video done, and that's because I started saying no to certain things, like, oh, I'll stick around for this or that, or stream every little tiny thing here and there. It's streams, I know that they seem like just a little window of time, but they actually take up a lot of time, especially when you're trying to do Starship streams. Those ones are very, very, very heavy. Or heavy. I read Delta IV Heavy. Those ones they're time heavy. They're time heavy. So yeah, today, again, I'm really excited about the Delta IV Heavy. I think this is a really cool rocket. It's the only rocket that flies. I think this is the only rocket in history that's entirely hydrogen. There's no strap-on solid rocket boosters. Am I right? Can you guys think of another entirely hydrogen-based rocket that was all upper stage, lower stage? So really, this is like the lowest carbon-emitting rocket flying. Yeah, pretty cool. Well, let's get to yeah, this is exactly Christopher Smith has this to say, which is exactly what I just said. I haven't covered static fire since like SN9. I kind of stopped doing them by SN10 just because it became right? It's a test of some engines. I mean, yes, I'm of course as excited as anybody about, all the Starship stuff, but I don't want to become a 24-hour news channel just trying to cover Starship. That my channel is not meant to be that. I'm not meant to, I was explaining this the other day that, this channel, I've never been one that's supposed to be space news. That's not what I do. That's not what I intend to do. It's not space news. I've always stuck to these kind of more broad topics that help you guys understand the physics and choices of spaceflight. I've only made like 2 videos ever that were like current event and like in the whole 4-year history of this channel. So I'm always confused when people are like, Tim, where's your video on HLS? It's like, I made a video last year diving into all the options with HLS, and it's still completely relevant and how it fits into the Artemis program, blah, blah, blah. But no, I didn't make a video about, the human landing system in Starship. I would love to, but I'm trying to stick to the video list that I have, which I think is more exciting. So, because yeah, there's plenty of great people. Again, like Miko, the podcast Miko with Anthony Colangelo, fantastic rundown on the HLS system. There's a lot of other YouTube channels, of course. Scott Manley covered it. There's a lot of people talking about it, so I don't see why I would also need to do that same thing. This is from Musical Wolves. Has the Delta IV ever delivered ISS supplies? This is a great question. Yeah, the Delta IV. So there was the Delta IV and there was the Delta IV Heavy. The Delta IV Medium, they would call it, which basically was the center core with 2 additional strap-on solid rocket boosters. No Delta IV vehicle, I don't think, has ever visited the International Space Station. As a matter of fact, the Atlas V only did a handful of times, if I'm thinking correctly. I think the Atlas V is the only ULA rocket to visit the ISS, and it did it when the Cygnus capsule needed a replacement ride instead of using the Antares. That was in like 2015. The explosion was in 2014, so the contract's OA6. I believe it was OA6 and like OA, they were super out of order. Like OA4 or something were both ISS missions with the Atlas V. But yeah, that was the only time that a ULA rocket, I think, has actually launched the ISS, if I remember right. Let me guys know if you guys are if you guys know different, but I think that's right. Let's see. So what is the size comparison against the Saturn V? Great question, Dan the Man. And guys, remember, just ask your questions in chat. We don't just pick super chats. We're trying to make sure that we focus on answering good questions for you guys. That's the whole point of this channel, is to answer relevant questions about spaceflight and help answer your questions. So just be sure, you know, we don't have to super chat to get up on screen here. We're trying to focus on that. But I also have to apologize. If you did super chat, I might not have a chance to catch it because I'm trying to really focus on answering questions. So Dan the Man 47, what is the size comparison against the Saturn V? So this is about 70 meters tall. Again, about the exact same height as the Saturn V. The Saturn V, of course, was 110 meters tall, if I recall offhand. So it's 40 meters shorter. The Saturn V's, the first 2 stages were 10 meters wide, then it tapered down to 7. This vehicle is actually wider than the Saturn V because altogether it has 3 5-meter cores, so it's 15 meters wide, a little more than 15 meters wide at the base from one side and 5 meters wide from the other. So it's kind of tricky when you have a configuration like this rocket. Hard to say like how much, how wide is it when it can be different widths at different angles and such. So it is quite a bit smaller. Here we go. We actually have the live stream coming up here from ULA. This is great news. Let me get this kind of pulled up here in the background so you guys can start watching. Give me 1 second here. I'm going to make sure that I am in the right place for this one. And let me go like this so you guys can just kind of see this. It's saying it's live, but it's not doing anything. Okay, well, we'll see if anything actually happens. Yeah. Okay, so yeah, it's still smaller than the Saturn V, but it's bigger in some ways. It's not as capable as the Saturn V. Of course, the title, I did have to change the title for you guys because you were being pedantic. It is the largest operational rocket currently flying. So of course, when Starship's complete, it'll be larger. It'll be the largest rocket, period, ever. ever. Why is the play bar staying up? Get out of there. Get out of there, Dr. Playbar. I don't want you. I'm just going to do that. There we go. Okay, so yeah, there we go. It looks like they're coming up on launch. This is a good sign. So yeah, so it is a little bit bigger in some ways. Okay, okay, let's listen in here.
At Space Launch Complex 6, a Delta IV Heavy rocket is fueled and ready to launch the NROL-82 mission for the National Reconnaissance Office. Good afternoon and welcome to Vandenberg Air Force Base in California. I'm Caroline Kirk, a systems engineer with ULA. Liftoff is currently planned for 1:47 p.m. Pacific, and the launch team is not working any issues at this time. Approximately 15 minutes ago, the launch count entered a planned hold. We have 2 planned holds in today's 9.5-hour launch count. These planned holds give our team additional time to resolve any issues that come up prior to entering the terminal count. At the request of our customer, today's live mission coverage will conclude following payload fairing jettison, scheduled to occur just over 6 minutes after liftoff. In addition to watching our webcast, you can follow live mission progress at ulalaunch.com.
I have to apologize. The audio is actually kind of bad on ULA's end, so I apologize if it sounds kind of crunchy. I can't do anything
The weather
about it.
conditions here at Vandenberg Air Force Base. Here's what we're seeing. The probability of violating launch constraints is 40%. The ground winds are 10 to 15 knots out of the northwest, and the temperature is 55 degrees Fahrenheit. So, the weather is within the launch commit criteria and looks favorable for our planned T0 at 1:47 p.m. Pacific.
That's like what, 15 degrees Celsius for those of you that don't know what Fahrenheit is. Let me do that conversion for you guys quick.
Today's flight will head south away from our launch pad here at Vandenberg.
13 degrees Celsius.
Let's take a look at what else we can expect to see.
5, 4.
So they're going to show the profile here. This is a good chance for me to answer a couple more questions because they posted this video on YouTube. So if you guys want to watch the launch profile, check that out. They do a good job of covering those. So this is a great question from Peter. Actually, we're going to see it right here. This question is, why do the flames go so incredibly high just before liftoff on Delta IV Heavy compared to the example of the Falcon Heavy? So watch this. This is perfect timing because watch this video here. You're going to see a flame climb up the side of the rocket big time. So what they do is they light in this view, the right engine first, about 2 seconds before they light the other cores. And what they do is they have these things called rofies that are giant sparklers, basically. The rofies don't actually have anything to do with the actual ignition of the engines. They're just there to make sure they burn off any excess hydrogen. Because as the engine begins to fuel up and begins to become up to operational temperatures and pressures and do all the things that the engine is doing before ignition, there's excess, there'll be some excess hydrogen that kind of builds up in certain areas. And if they didn't get rid of that and burn it off, it could have this much larger, much more energetic flame wall. So instead, what they do is they intentionally just light the excess hydrogen on fire, and it climbs up the rocket. It gets it a little bit toasty, and then they light the other two engines. And by that time, a lot of the excess hydrogen has kind of, died down a little bit, and then they can safely launch the vehicle. Now, this is actually that flame wall is one of the reasons that it's not human rated. This vehicle, the Delta IV Heavy and the Delta IV Medium, were never considered rated for human flight. The RS-68 isn't a human rated engine, but also that flame wall was part of the consideration why it would never see human flight. So yeah, let's see. This is from Alexander. Alexander Ash wants to know, what is the point in rockets like the ULA when they aren't reusable? Surely it's a waste of money because of space debris stuck in the past. Well, space debris isn't really much of a bigger concern. The vehicle will always, put its remnants into a graveyard orbit or deorbit itself, so it doesn't have anything to do with being reusable. Now, to answer that question, I think a lot of it is you guys have to only go back about 5 years in time to realize just how insane the promise of SpaceX's rockets were. Before December 21st, 2015, so yeah, just over 5 years ago, really no one thought it was possible to do what SpaceX is doing right now with the Falcon 9. And the market moves really, really, really slowly in the rocket world, right? The flights that were booked on this particular rocket were booked years and years and years ago. The satellites designed for this mission were developed years and years and years ago. It just takes a long time for the market to catch up to the demand. And as a matter of fact, even the Falcon Heavy has only been operational for about 3 years now. And it wasn't going to be winning a $1 billion national reconnaissance, we don't even know how much, we'll just say $1 billion, a really expensive satellite that's extremely important. They're not going to be winning those contracts until they're flying regularly. Now, on these next round of bids, on the newest, the newest things from the National Reconnaissance Office and the military, SpaceX was starting to win more and more contracts. ULA still was in there because they're so tried and true and reliable. But really, just what SpaceX started doing is just really beyond what 95% of the industry thought was even remotely possible, right? So in order to catch up to where SpaceX is, it's going to take a big change. And ULA has been making big changes with their upcoming Vulcan rocket. Now, personally, of course, a lot of us might have doubts on whether or not it's enough, if it's too little too late, because it's not going to be fully reusable. They do plan to eventually reuse the engines on the Vulcan by recovering them. But they aren't, they're taking a lot of precautions on how you can just make it cheaper for manufacturing, make a lot of common parts, have a lot of performance. So the Vulcan's going to be an extremely high performance rocket. So hopefully they're hoping to win out on a lot of those bids because of that. And the legacy, the heritage of these launch vehicles is why they keep winning bids like this. Now, how long is that? The real question at this point, in my mind and a lot of people's mind is, for how long can that dominance exist when there are cheaper options on the table, right? So that's kind of where we're at right now with the Delta IV and Delta IV Heavy, or Delta IV Heavy and the Atlas V and the Vulcan. But again, remember, rewind 5 years ago, and this was like the only option. Well, currently, this is the only option still. Right now, the mission that this is flying today, we don't know the exact parameters. It's likely a direct to geo insertion and a very heavy vehicle, very heavy satellite. It might only be capable of doing that on this particular rocket. Ooh, hold on.
0. Roger. VSE, LC.
VSE.
They're getting ready for the go, no go.
Step 1180, verify base bending moment instrumentation is active and data is valid.
DBM is fully mission capable and recommend placard 6 alpha.
Roger. LO, LC, net 1.
Here's the LO.
I'll be utilizing placard 6 alpha.
Copy 6 alpha.
Today's launch is for the National Reconnaissance Office, or NRO. This is ULA's 31st launch for the NRO and 9th use of the Delta IV Heavy for the NRO. The NRO is a joint organization engaged in the research and development, acquisition, launch, and operation of innovative overhead reconnaissance systems necessary to meet the needs of the intelligence community and the Department of Defense. The NRO is recognized for its transformational intelligence collection systems that are used to develop highly accurate military targeting data, support international peacekeeping and humanitarian relief operations, and to assess the impact of natural disasters.
All right, so until they start talking again, I'll answer a few more questions here. First, Keegan, thank you. Yeah, the channel's getting very close to 1 million subs, which I never would have imagined was going to happen. I had no idea. I had no idea this channel was going to do that. Oh.
On today's payload fairing.
I like this.
The details on today's artwork were inspired by a World War II fighter pilot who was awarded the Medal of Honor, a Navy Cross, and Purple Heart for heroism and dedication, and who had ace fighter pilot skills. This patriot was Gregory Boyington, known to many as Pappy. This logo was designed to commemorate the many heroic acts and sacrifices that have been made to protect America. The artwork features an eagle, symbolizing freedom, wearing traditional World War II flight gear. Behind the eagle is an F-4U Corsair, the aircraft that Pappy Boyington flew while in the Marine Corps. Additionally, we have the Latin phrase Tacitae Libertatis Custodumque, which translates to Silent Guardians of Freedom. Below the mission artwork, there is an additional patch recognizing the NRO's 60th anniversary this year.
Sweet. Okay, so I saw another one. Okay, so Stefan wants to know, of course. Of course he does.
NROL 82 is ULA's 90th national security mission. Gary Wentz, Vice President of Government and Commercial Programs, talks about the significance of these missions.
We're really honored to be here today.
Okay, I feel like they honestly always have these, and they're always like, we are so happy to be launching. So let me answer the question of, ULA is cool and all. I agree. But what I think we really want to know is, when is SN15, is it flying this week? So for me personally, the Tim Dodd meter is, I'll bet the first day that it's actually on the pad, attempting to be fueled up and actually like ready to fly. The first attempt I think will be Friday in my book, in my guess, which means I'm likely going to be heading back down to Boca Chica soon. I'm betting it's a little bit of a risk because I'm hoping that after the static fire that there's a little bit more time, maybe another static fire or two or whatever, as there always is on Starship. So I am personally betting, if you want my personal opinion on this, I'm personally betting that SN15 flies no earlier than Friday. That's just, having done this now for, studied every waking minute of Starship and when it might launch for 2 years now, ever since Starhopper, my gut feeling is it will always be several days after its first static fire. At least like 3 or 4 days. So that's the Tim Dodd meter on this one is no earlier than Friday at this point. If it doesn't static fire today, still maybe Friday. Say it doesn't static fire until tomorrow, still maybe Friday, but maybe even more likely Monday then, in my opinion. So,
OSM, verify the whole fire switch is in the proceed position.
Today's flight is dedicated to frontline workers who have been vital to the fight against COVID-19. This mission is also in memory of two NRO teammates. A few moments ago, Mission Director Colonel Chad Davis remembered these friends and colleagues, Lisa Wilson and Ross Kobayashi. Let's listen in.
I do want to hear these.
Today's launch is dedicated to the memory of past NRO teammates, notably including Lisa Wilson, engineer, friend, wife, mother and grandmother, who for 32 years provided unbounded support and technical direction for critical space lift missions, resulting in precise orbital insertion of satellite vehicles. Lisa's achievements are to be remembered as an example of service of the freedoms we stand for. Go for flight. And Ross Kobayashi, mentor, friend, husband and father, who for 25 years had been part of the OSL mission assurance team, responsible for the assessment of launch vehicle risks and the success of over 50 national launches across the Titan, Atlas, and Delta launch systems. Ross served as the technical chair for 28 NRO launches, leading the efforts to safely shepherd the payloads to orbit, culminating with the launch of NRO L-71 from Slick 6. Fight on forever, Ross. MD out.
Honestly, that's so cool to me. I mean, that would be an amazing way to be memorialized. Just super cool.
Preparations for launch continue. In a few moments, launch conductor Scott Barney will poll the launch team for the final go to pick up the count. 27 engineers and managers are polled for system status and readiness to proceed. This is the final status check before launch for all Delta vehicle systems, ground systems, the spacecraft, and the U.S. Air Force Western Range. The vehicle system readiness poll includes electrical systems, hydraulics, pneumatics, propulsion systems, flight control, and propellants. Let's listen in as Scott Barney performs the final polling of the launch team.
This is honestly like one of my favorite parts. I wish you'd hear that just for everything.
Terminal count. First stage systems. Propulsion. Go. Hydraulics. Go. Locks.
Go.
LH2.
Go.
Second stage system. Locks.
Go.
LH2.
Go.
Electrical systems. Airborne.
Go.
Ground.
Go.
Facility.
Go.
RFFTS.
Go.
Flight control.
Go.
COM.
Go.
GCQ.
Go.
Operations support.
Go.
Pneumatics.
Go.
Umbilicals.
Go.
HAZGAS.
Go.
ECS.
Go.
Red line monitor.
Go.
Quality.
Go.
Ops safety manager.
Go.
ULA safety officer.
Go.
Vehicle system engineer.
Go.
Anomaly chief.
Go.
Range coordinator.
Clear to proceed.
Launch director.
Launch vehicle is ready to launch.
Mission director.
You have permission to launch.
Proceeding with the count.
Oh,
Yes.
minus 6 minutes.
ALC. Verify T0 is set for 20:47:00 Zulu.
Verified.
MEQ. Establish swing arm lock pins pole.
Active.
Yes.
Polling is complete, and the launch team has given the go for launch. The countdown will resume approximately 2 minutes from now. At T-minus 4 minutes and counting, we will enter the terminal count and begin securing the second stage liquid oxygen tank. At T-minus 3 minutes and 32 seconds, CBC liquid hydrogen and liquid oxygen tank securing is started, including closing the propellant fill and drain valves. Also, at T-minus 3 minutes and 32 seconds, vehicle transfer from ground facility power to its own internal battery power will be complete. At T-minus 3 minutes, the vehicle ordnance system will be armed and the CBC liquid oxygen and liquid hydrogen propellant tanks are verified to be at flight pressure and flight level. At 2 minutes prior to liftoff, the team will verify that the hydraulic system is pressurized and confirm CBC, DCSS, and FTS battery voltages. At T-minus 1 minute and 20 seconds, the team will begin securing the second stage liquid hydrogen tank. At T-minus 60 seconds, Western Range readiness is verified. At T-minus 50 seconds, the DCSS liquid hydrogen tank is secured at flight level. At T-minus 15 seconds, the launch table HBOs are ignited at the base of the vehicle to burn off excess hydrogen. At T-minus 7 seconds, the starboard CBC engine is ignited. At T-minus 5 seconds, the port and center CBC engines are ignited. Liftoff will occur at T0.
So I'm working on actually like totally syncing up our clocks because they just give us an approximate time. So we're gonna wait until. So notice that my clock was ticking the whole time, and they put theirs in a hold because they have this whole built-in hold thing. It's different. So I'm trying to give you guys the actual time until launch. There we go.
3:55.
Ground pyros enabled.
The countdown clock has resumed. We've entered the terminal count and are go for launch at 1:47 p.m. Pacific time.
So in my opinion, guys, I think this is gonna go today. I think they're gonna just get this off the pad. I think they're gonna get this off the pad right away because the last Delta IV Heavy they launched scrubbed for months and months. I don't think the NRO is very happy. I think they probably sat back and guys, we have to knock this one out of the park. That's what I think they're going for today. I mean, obviously, they don't want to scrub a launch ever. It just costs more for them. It frustrates the customer. But I really think there is some extra urgency on this particular launch to just get it absolutely right. So my bets are that as long as the weather's okay, I bet this vehicle's been checked over with the finest tooths of Combs' finest toothed comb, and all the ground systems are totally ready for today. That's my bet. I really hope I'm right because I really want to see this thing launch today. So what do you guys think? I hope that we see this. We'll answer a bunch of questions after the launch. This will be a short launch because they won't even show us the upper stage trajectory because of it being national security. So I will stick around and answer lots of questions for you guys here. So just get ready. We are now at T-minus 40 seconds or so. So the other concern though is the ground hydraulics and some of the closeout valves. When it's cryogenic fuel like this, it's all liquid hydrogen, which is extremely cold, and liquid oxygen, which is still cold. But this is where the things tend to get finicky with this rocket because the cryo valves can stick and stuff like that. So let's see if they're going to get through all the way down to T0 and get a good launch today. So let's listen in here. Oh, I should definitely mention this rocket has triple pointy end and triple flamey end, and a very flamey end at that. So I better double check that. I want to confirm the pointy end is up and the flamey end is down, my friends.
159.
Here we go.
Vehicle internal. 155.
Launch sequencer start.
They're getting pretty deep into the countdown. I like this. This is looking good.
140.
FCS launch enabled.
137.
So the flight termination system was just enabled. So at this point, there's actually a actual device on board that if it were to go off direction, they can terminate the rocket.
90 seconds. The launch vehicle, payload, ground systems, and Western Range are go for launch.
120. Supposed to use ARM.
FCS count started.
All right, guys, we are T-minus 1 minute here.
T-minus 1 minute.
Engine soapbox go.
Rock, report range status.
Rock, range is green.
That's good. That's the range safety
50
officer.
seconds.
All right, so don't forget, guys, we're going to see this thing literally light itself on fire at starting about T-minus 7 seconds or so. That's normal.
30 seconds.
Status.
T-minus
Go
30
Delta.
seconds.
Go NROL 82.
Sweet. They're doing it, guys. The clock did turn off.
15 seconds.
Roll for ignition.
10, 9.
T-minus 10, 9, 8, 7, 6, 5,
There we go. That's
4, 2,
normal.
1, and
Yes. Yes.
liftoff of the United Launch Alliance Delta IV Heavy rocket carrying the NROL-82 mission for the National Reconnaissance Office.
You go on the pitch over maneuver? Parameters look good on all three cores.
I knew it. I knew it. So California, if you live in Southern California, Ventura, LA, San Diego, look west. And within about the first 2 minutes, you'll actually be able to see this rocket because it's extremely bright.
Partial thrust achieved.
You are hearing the voice of Rob Kesselman providing launch vehicle ascent data.
Now, 50 seconds into flight, vehicle is 3 miles in altitude, 5 miles downrange distance, traveling at 970 miles per hour.
I do want to point out real quick, now look at how bright these engines are and the fact that there is an orange flame. This rocket burns hydrogen, so its flame is actually supposed to be completely clear, just like the space shuttle's main engines. It runs on liquid hydrogen, so the byproduct is literally just water vapor, which is actually what we're seeing right now as it goes through a certain portion of the atmosphere where it's easier to make condensation like that. But notice that the flame is orange. And that's because this rocket has a more simple rocket engine than having to regenerate the walls with the fuel. Instead, they literally have an ablatively cooled nozzle. The R68A has the whole rocket nozzle is intentionally flakes away. And when it flakes away, it takes some carbon away with it. So what you're seeing is that bright orange flaming glow of carbon. Same with like an RP1 engine with say a Falcon 9 or Falcon Heavy. What you're seeing is the carbon that's emitted, the extra carbon from the exhaust, igniting in the atmosphere as an afterburning effect. This rocket is quite literally eating some of its nozzle and ejecting some of that carbon out the back of it. So, yeah, I just think that's fascinating that it still glows orange even though it's completely clear flame because it's eating its own engine.
On to closed loop guidance. Vehicle body rates are nominal.
It's doing a little roll here. Yeah, this is basically an engine-rich nozzle. That's exactly a nozzle-rich engine.
3 minutes remain in the booster phase of flight.
Intentional. Oh, that's a cool shot.
Delta IV rocket now weighs just 1/2 of what it did at liftoff, burning propellant at a rate of almost 5,000 pounds per second.
That's a cool shot. I love seeing those telescopes out there.
1 minute until port and starboard booster engine cutoff.
So everything's looking good so far, guys.
Vehicle systems look healthy at this time. The attitude control system, autopilot has controlled all vehicle body rates to near zero.
So get ready in about 30 seconds.
Approximately 30 seconds remaining now until the port and starboard booster engines cut off.
Yeah. So that's a camera looking down the center core. You're seeing the nose cone of one of the engines there.
Strap-on boosters are now throttling down to the partial thrust level. Strap-on booster cutoff and separation of the strap-on booster. Core booster is now throttling back up.
I love that shot.
Core booster is operating as expected at the 100% throttle level.
Here's something that's kind of interesting. The way it controls its roll, because it only has a single engine, right? So how do you control the roll? You know, if you have just one engine going up through the middle of your booster, how do you control the roll? If that engine, you know, you can control pitch and yaw, but how would you control roll? What they actually did, and it's really smart, they took the exhaust from the gas generators, because it only uses gas generators. It's not closed cycle, it's open cycle. They use the exhaust from those, put them out, like stuck them way out on the engines, and put little gimbals on those so they can actually point those in opposite directions and use the exhaust from the gas generator to help steer the rocket, which I think is actually really cool. Really, really cool and simple solution. All right, so this will burn for another minute or so, I believe.
Booster performance continues to look good at this time.
So don't forget what they actually do. There's no fuel crossfeed between these boosters. They just throttle down the center core so that it, after it gets off liftoff, it, helps aid in getting all of that heavy rocket off the pad. Then they begin to fuel it. They throttle it down so they just save fuel in the center core. So once they jettison the boosters, they ramp up that throttle back up on that center core because they saved enough fuel to basically have it burn for an extra 2 minutes.
Now throttling down.
So basically, if you think about it, if it needs to burn for 6 minutes, if for 2 of those minutes it's burning at half throttle or whatever, do the math, I don't know. Yeah, so...
We have stage separation.
Yes. Now watch the
Next
nozzle.
deployment
See
has begun.
For a second, you can kind of see
Reset
the
on the
nozzle.
RL-10.
There we go.
We have ignition on the RL-10. That's one.
I'm sorry, but that is so cool. I know this rocket is old school, but it is so cool. And I think this is going to be the end of their webcast now because it's the National Reconnaissance Office. I just think it's cool. I like the way, I like
This
the
year,
old school
the
way of
National
doing things.
Reconnaissance Office celebrates its 60th anniversary. From its inception in 1961, the NRO has used its incredible intelligence collection capabilities to meet the nation's challenges. Let's take a look back at the agency that has pushed the envelope of U.S. space-based intelligence collection with courage and ingenuity.
Okay, cool. So again, they post these online. This is probably literally the end of the webcast for them, so I'm going to answer some more of your guys' questions. Yeah. Let's see. We kind of talked about this really quickly. Carson Lund. Again, guys, remember, if you have questions about what you just saw, get it in the YouTube chat. Remember, you don't need a super chat to get our attention. If we have time today, I'll go ahead and answer as many as I can. But Carson Lund, a chat from YouTube, just asks, would this rocket ever be human rated? No. First off, there's only 3 more. Now, this was the 4th one ever, 4th to last ever. There's only 3 more. This rocket will be completely obsolete once it's done. So, of course, it will never change it to make it human rated. And it was never designed to be human rated. There's actually quite a few considerations, that would be drastic design decisions, different engine, likely different fuel. Yeah, there was really no chance of that vehicle ever being human rated, and now it for sure will not be. This is a great question from from Stavato04. What makes the Delta IV Heavy better or different to other vehicles? How is it special? Really good question. So one of the biggest things is it currently flies the largest up and most powerful upper stage. So the bigger your upper stage is, the more potential it has, and it's a hydrogen upper stage, so it has it's extremely efficient. When it runs on that RL-10B2 engine, that upper stage can do a ton of work. So you just have to get it up there. It's so big and heavy, you have to have a big rocket capable of putting it up there. So what they do, this means they can put a satellite on it. They can get it up into orbit. They can get it out to its geostationary transfer orbit, which is that elliptical orbit that takes it from low Earth orbit out to the, 27,000 kilometers or 28,000 kilometers or whatever. I don't remember exact 40,000. I don't remember. Let me know. Far out there. And normally a normal rocket like a, Falcon 9 or a Falcon Heavy or an Atlas V, they tend to just leave it there. And then it's up to the satellite, once it gets up to its apogee, to its highest point, to actually increase its own orbit with very low powered thrusters. And it can take months to actually get into its final parking orbit. Now, one of the capabilities of the Delta IV Heavy, because it has such a powerful and massive upper stage, is it still has enough fuel left in its tanks after that geostationary transfer orbit to get up to apogee, coast up there, relight its engine again, and put the satellite straight into geostationary orbit. It's just called a directed geo insertion. It's really hard to do because you have to save enough fuel to be able to do that additional burn, which is a substantial burn. And I don't know if that's exactly what this particular mission required, if this is a directed geo mission or not, but it's safe to say that, it's a capability like that the National Reconnaissance Office potentially needed. So basically delivering the satellite straight to where it needs to go and get it deployed in days rather than months. So good thing this thing took off today. I'm really happy and I'm proud of ULA for knocking it out of the park again, like we expect to see from them. This is why they get paid the big bucks, is because they had a target date and they actually knocked it out of the park. So, so good question. Let's see if they're going to give us any more updates. Likely we won't get any more updates.
Delta Mission Control at T plus 10 minutes. Rob Kesselman just confirmed the successful completion of the early phase of today's flight, and all systems continue to operate nominally. I'd like to thank Rob for his support of today's show. For more information about this mission, please follow us on Facebook and on Twitter, or our blog at ulalaunch.com. We'll leave you now with another look at the liftoff of the Delta IV Heavy rocket carrying NROL-82 for the National Reconnaissance Office. I'm Caroline Kirk, and on behalf of the entire launch team, thank you for joining us and have a great day. 8, 7,
I always appreciate that they do these instant replays right away too. So yeah, we'll watch this replay and then we'll just answer some more questions for about the next half hour or so for you guys. This is a good question. SB Sabuni says, why did Delta Heavy choose the fuel they use? So really there's pros and cons to quite literally every decision on a rocket. You change one little thing and it changes everything, right? You can't just be like, I'm going to do this. So likely they were trying to, I don't necessarily know why go for hydrogen over, you know, you can get a lot more performance, potential performance out of, that's it for the broadcast. You can get a lot more potential performance out of hydrogen than you can RP1 or any other fuel. It's the most, for liquid fuel, well, it's not the most because you can actually use there's some like tri-fuel options that are really high efficiency. But for like off-the-shelf fuels, liquid hydrogen has a lot of performance. You can burn it. It just has a lot more potential energy. So if you make a rocket, in theory, out of all hydrogen, you would think it has a lot of performance. Now the problem, hydrogen is so undense, it's so sparse, that this rocket actually has like half the thrust of the Falcon Heavy. Because it's, although it's huge and looks massive, it's not nearly as heavy because it has huge tanks because hydrogen is so sparse or so undense that it just takes up a lot of volume. It's very voluptuous. I don't know if that's correct. But so the rocket looks a lot bigger than it is. So if this was a comparable, say, Falcon, or a comparable rocket with purely, even methane would be a lot more dense, or RP1, it would be a lot heavier vehicle. So it's kind of this weird trade-off. There's lots of decisions to be made. I can't speak for why exactly they made all these decisions for this particular rocket, but yes, I did say voluptuous. From Andrew B, thank you for the super chat. Do you think that Ingenuity could use its rotor wash to dust off the solar panels of Opportunity? Well, if there are no solar panels on Oppie, no, because it's way too far away. Opportunity is like even if it was within 200 kilometers, which if you think about how big Mars is, that's nothing. That'd be right next door. Ingenuity's not flying over there. Well, okay, I'm not going to say it's not because frankly, you never know with JPL. Knowing them, this little thing that was supposed to only fly at best 5 times, basically, it might end up flying for like 30 years because they over-engineered it. And it's going to they're like, you know what, screw it. Let's do that. Let's fly over to another rover. I'm not going to say it is pretty much out of the question, but I'm not going to say no. I don't want to be Peter Beck and eat my hat here. So maybe, no, but no, but maybe. No, absolutely not, but maybe. Yeah. Okay, so this is from Adam Mish says, do you happen to have any idea how this rocket capabilities will compare to the fully operational Starship? I feel like we did that in a video, did we not? Did we not have a video that shows the exact performance difference between Delta IV Heavy? I'm trying to think of what that would be. It's a different class of rocket. Now, this is a heavy lift launch vehicle. It's not a super heavy lift launch vehicle. So that is, I know that people go, well, you can compare the two. But it's kind of like comparing a 747 versus, something a lot smaller, like a 737. They're different class of jetliners. So, yeah, I think, and by the way, yeah, that's true. ULA will basically be, Delta IV Heavy will almost be done by the time Starship's operational. But I think I had that, it might have been in the Blue Origin in the, is New Glenn the King? I'll just type that in. We'll probably find this article. I think. Let's see. Maybe not. Did we not have that as? I don't remember if we had that as or just this. Well, hi, it's me. Come with me. We're gonna go on a little stroll here through the engines thrust capability. Here we go. So this is an old video of mine. So sorry that it's ugly. But yeah, that shows how this is basically to geostationary transfer orbit. You can see the Delta IV Heavy has a lot of capability there. And I think we also had a LEO capability too, if I remember right. Where was it? I don't know. Old video, not very well laid out. Not very good. But it will be substantially less capable than Starship, except for to Geo, it's similar because Starship can only take, what is it? 12 or 14 tons to geostationary transfer orbit, not to direct to geo, because it has to lug around all of the dead weight. You know, Starship's dry mass is huge because all that landing hardware carries around its cargo bay. It's in order to do high performance missions like geostationary transfer orbits or direct to geo, they have to do refueling. So it has, you know, of course, has a lot of potential to do a lot more. But yeah. All right. This is SSG Stanford. Thank you. When we all know you are Bob Ross's secret love child. When are you going to start making paintings with these happy little launches? That is very strange. Someone once did say I was the Bob Ross of something, and I just had never recovered from that. That is the highest compliment I think one can get, but I just don't think that's anywhere true. I think Bob Ross is a saint, and I am just not. I do want to do some paintings, though. I have an idea for a painting series that I want to do. I think that a lot of people forget that Everyday Astronaut actually started off as an art project, and it wound up here, which is weird. But growing up, I always thought I was just going to be a professional artist. Didn't happen. I guess I mean, in a way, no. The photography I did I was not living off fine art photography ever on any stretch of the imagination. So no, I was never capable of being a full-time photography artist, let alone I wanted to draw. When growing up, I just assumed I'll be a good enough drawer that I can just make a living drawing. Well, I also thought I'd be at one point a scorpion trainer. And another point, I thought I was going to be a tractor when I grew up. That obviously didn't work out. And I also thought I'd be a prosthetic engineer. So I've had quite a slew of different options, but I just, most of my pre-adult life, I thought I'd be a professional drawer. Drawist. All right, this is, hey Tim, I was wondering what you thought of the success of Moxie on Mars. Also, we'd be covering any of Ingenuity's flights in the future. Great question, Agent Kevin. So basically, those would be really boring streams because we don't get the video back from those flights. They're so far, I think the most recent one was 50 seconds. Incredible, huge milestone, way beyond what I was hoping. I mean, I'm super happy with Ingenuity's success, but those would be terrible live streams because they'd be like, well, we got data back that confirms it had flown. I'd be like, yay. And then we would wait like 2 days to get the data back from the actual, to get some kind of video file of it because it is on Mars and there's very low bandwidth between Earth and Mars. So no, I will not be doing any of those. But I am very excited about Moxie. Now, Moxie is a in situ production plant for making oxygen on the surface of Mars. Huge deal. Very, very big deal. And so far, it's been going great. It's been going exactly as planned. It is just like Ingenuity. Moxie is a technology demonstrator. It doesn't have any, like mission critical purposes or any real thing other than to test the theory that they work, right? So there is, this is looking good for being able to produce oxygen for humans on Mars, which is extremely, extremely important. Or even producing, this is a little bit different than producing the fuel on for Starship on Mars, because obviously Mars you have for Starship on Mars, sorry, you have to produce liquid methane and liquid oxygen, and they can do that using the Sabatier process. So by taking some of the ice water, turning it into, melting it into pure water, splitting that up using electrolysis, I believe, and then injecting carbon from the atmosphere to make it into liquid methane, and it also produces liquid oxygen, which is a total awesome side effect. So yeah, but still Moxie is, some of that portion there's a lot of similar chemistry. So introducing it on Mars is awesome, and making sure that it all works out is super, super cool. Let's see here. Thank you very much for the membership. So Hampus says the Delta IV Heavy is the largest operational rocket, but this Falcon Heavy is most capable, right? Depends. Some missions, when reused, Falcon Heavy is less capable by pretty much every metric. But if it's expended, it can outperform in most metrics. I still think there are a few situations that the Delta IV Heavy will outperform Falcon Heavy. Specifically, I think that straight to geo metric, where the upper stage does a lot more of the legwork. We won't likely see too many fully expended Falcon Heavies. Obviously, there will be some, and it will be the maximum performance version of the Falcon Heavy. But the Delta IV Heavy still has an awful lot of performance due to the high performance nature of the engines and everything like that. So, Let's see. This is from Ladmir. Says, when we do some videos about Russian rockets, can't wait. Well, that is a great question. So I've talked about it a few times on Twitter, but we'll be doing a big push here really soon. The plan at this point is to actually, we've had so much work done on the video all about the history of the Soviet and Russian and Ukraine and prior Soviet Union's engines and all of their whole history and how they've kind of evolved and stuff like that. We've had so much work. It's been over a year of work. I mean, granted, for the last 6 months, there hasn't been much work on it. But I think we're going to just do it right. And I think we're going to just film it in Russia. So go to Russia, get lots of good, high-quality B-roll of a lot of these engines that are over there. So we require a lot of cooperation. Get out to Kazakhstan, maybe try to see Buran. And if not, then at least we can see it in Germany. But we're going to try really hard to actually produce a proper, full-blown documentary that is like, full 2 hours with, original content, original interviews, original B-roll, and just really not rely on these old grainy re-uploads on YouTube. Try to get it so it's actually good. You know me and my obsession with quality. A lot of the stuff in this video will just be, at this point, just CGI, and like, no, Casper's done an amazing job of making every engine. We will be using that in the charts and stuff, so don't panic, Casper. We will still be using all of your renders that I hired you out to make. But, at the same time, there's nothing like seeing original or maybe try to get some films and redigitize them so they're high quality. I want to do this right. And of course, when this is done, it will be completely free on YouTube. I'm not going to be selling it off to Netflix or anything. I really do believe that having information out there for free is the best situation for everybody. I think that works best for everyone. So it will be free once it's done, but it's going to be a lot of work. It's going to be an uphill battle, but I think it'll be absolutely worth it. And you guys know me and my rabbit holes. This is one of them. Ozzy G comments on the impact SpaceX is potentially having on the Boca Chica beach. There's been recent backlash from locals, Brownsville native here. Ozzy, great question. That is a loaded question, as you know. The locals have had access to that beach since the beginning of time. It is a local public access beach where you can drive on the beach. There's no other commercial development anywhere nearby. There's no hotels. You can just enjoy the beach. It'd be completely one with nature. And it does suck that SpaceX, with their mission, is tying up a lot of the time and access to the beach. Personally, my personal bet would be, what would be a great compromise would be to gain access to the north end of the beach from South Padre. That way, even on, certain days where they have a smaller, if they're just doing some testing of like, say, a wet dress rehearsal or a static fire, people can still use the north, like 2 miles out of the 5 mile beach or something like that. Then they block off access from there on or something. So they'd either have to do a tunnel or a huge, huge bridge or a ferry or something to get people to the north side of the beach. But that way SpaceX can utilize that stretch of the highway there, close it all off, have it as their own personal. I think this will happen personally in the next 2 or 3 years. But I do think either SpaceX will have, if they don't want to try to get, maintain access to the north end of the beach, I think the next best option would be to try to buy up a bunch of land on South Padre Island up north and have it be a public beach of the same size, just basically, square foot for square foot or acre per acre or whatever, and have that be a public access beach. Because I do think there's, there should be, just because a corporation wants to do something awesome doesn't mean they have the right to. There should be a trade and a fair way of doing things, in my opinion. Obviously, you guys know I'm the biggest fan of SpaceX, so I want them to continue with Starship's development as fast as they can and with as few hindrances as possible. But it's not fair to the local community to be taking away access to a public beach. So, there's some compromise there, and I'm sure they'll figure it out. All right, from Antonio. Love your channel. Are the launch parameters for ULA the same as NASA and SpaceX? So there's each rocket in particular has a particular set of things that would, cause it to scrub or things that they need to tick off kind of on the pre-flight checklist. But as far as flying the actual rocket, the range safety officers are almost always the same. They're actually usually Air Force range safety officers. So when NASA launches a SpaceX rocket or SpaceX launches or ULA launches at, Vandenberg well, I guess, sorry, I should say when they launch from Florida, you know, they use Patrick's Air Force Base there for the range safety. And then when they're launching from Vandenberg, they use, you know, Vandenberg Air Force Base for range safety to make sure that the areas are clear. So it just depends. The actual perimeter, you know, different vehicles have different capabilities for weather. The Falcon 9 is very prone to scrubs if the upper level winds are too strong because it's so skinny it could snap from big, strong cross-directional wind changes. That's something that Delta 4 doesn't have to worry about quite as much. But then the Delta 4 Heavy is more prone to ground winds compared to, say, the Falcon 9. So, you know, there's different bounds for basically every rocket and everything. So, but as far as the actual range clearances, that is done. They pretty much all abide by the same range clearances. So, yeah. This is from Nico. SpaceX is like Apple in 2007. Nobody believed in the iPhone, but Apple only focused in the vision of the future. They changed the whole industry. This is absolutely true. You know, it was an uphill battle when they first released the iPhone. Everyone's going, this is so stupid. And now you will not find a new phone that doesn't look and basically do the same functions as what Apple innovated on for the original iPhone. Let's see. This is from Tyrandus. Says ULA has historically remarkable accuracy for launches. Accuracy literally here in terms of correct orbits, whether LEO or out into the solar system. You are correct. So of course, that is absolutely right. That is one of the things they kind of brag a lot about, is how precise they actually nail their target. Lots of times Tori Bruno, the CEO of ULA, will put up the actual, like, a bullseye and show how close exactly they were in their altitude, their inclination, and all that stuff, and how close. And they are like bang on, and that is important because if you don't absolutely nail the destination of the orbit, the spacecraft has to use its own onboard fuel, which there are limited amounts of fuel for the spacecraft to be able to do any onboard maneuvering. So if it has to waste a bunch of its fuel just to correct the orbit, then you're shortening the lifespan of the payload. So, yeah. Let's see. Don't trip. I'm not sure. It may have been visible today. I did mention it. From distance-wise, absolutely, you'd be capable of seeing it. Whether or not you could spot the bright trail of it, I don't know. It is obviously a lot more. You'd easily see it at night, but during the bright day, I'm not sure. So this is from how you might have animated that. This is a great question, and I know I say that often, but this is a really good one. This is the topic of a video that I have begun scripting, although it's probably going to get pushed back quite a while. We have a lot of other videos to get to first, but why not use this rocket to send people to the moon instead of the one they are wasting money on? Well, this rocket would not get the Orion capsule to the moon. It cannot do it. The Orion capsule is, how heavy is it? We talk about it in my SLS versus Starship video, but we talk about how heavy the Orion capsule is. I forget. I think it's like 17 tons, or with its the European service module. It's big. It's really heavy. Delta 4 Heavy, even though it's extremely powerful, is not capable of getting that thing out on a TLI or a translunar injection. It will just simply fall short. It would not be able to do it, and it's not human rated, nor will it ever be human rated. So, yeah, that's why. Connor says, do I like Joe Barnard? Joe, if Joe's watching, he knows the answer to this because he can feel it in his heart. You guys, most of you probably know the answer to this because you also can feel it in your heart. Who doesn't not only like Joe Barnard, who doesn't love Joe Barnard? I think that might be physically impossible. So the answer, do I like Joe Barnard? I don't like Joe Barnard. I love Joe Barnard. He's actually a good friend of mine. We've hung out a couple times. He actually helped. I shot 3 years ago now. I shot a full series for Facebook when Facebook was doing like original series called Facebook Watch. So I did a series called Spacing Out with Everyday Astronaut, and Joe was in that series. So we hung out for like 2 or 3 days out in Tennessee. It was super fun. We stay in touch often. We hung out down in Florida again. I'm trying to get him out to see a Starship launch, to see an SN launch. And I think I'll get him out there. And in which case he'll definitely be like co-hosting with me the whole time. So it's going to be, oh yeah, there we go. Orion is 22.7 metric tons. It's a big old thing. So yes, I love Joe Barnard. You guys hopefully all like him. I had a shout out of him in the most recent video from his attempts at doing suicide burns with a solid rocket motor. So yeah, obviously a huge fan. Huge fan. Okay, so again, I kind of touched on this a little bit, Everyday Space, asking why are they not using Falcon Heavy for this mission? Wouldn't it be cheaper? So again, when they bid out this mission, lots of these NRO missions were bid out like 5-6 years ago. Falcon Heavy was completely still, most people were saying impossible and that it'd never fly. So by the time Falcon Heavy flew and actually proved that it's capable of doing what it's doing, now it got into the newer bids that most of those bids just came up last year in 2020. So Falcon Heavy in 2020 was winning bids for missions that we'll see in like 2023, 2024, 2025. But until then, we're seeing a lot of these missions that were bid on 6 years ago before Falcon Heavy was ever even a thing. So a lot of it was like, yes, of course, but the industry moves kind of slow. So it goes both ways too. If you have, say, the satellites shrinking and you don't need as big of a rocket to fly, it might take a while for the launch providers to start making smaller rockets to just cater to those smaller satellites, because you don't need to buy a whole Falcon 9 if you're putting up something that Falcon 9s could launch 10 of them or something. You only need to launch one. So, I mean, obviously you can do ride shares and things like that, but it took a while for the industry to start making small sat launchers like Rocket Lab and this whole slew of other new small sat launchers. But vice versa, it takes a while if someone develops a cheaper rocket for the industry to catch up to that as well, to catch up to those capabilities. Like when Starship goes operational, it's going to take like 3 or 4 or 5 years for the industry to catch up to that, being like, oh, wait, we can make a satellite as big and heavy as we want, and it'll be cheaper than anything we've ever flown on before. So let's not spend all this time with research and development and all this extra engineering trying to shave off every gram. Let's just make it the size of a house and have it be 3 times heavier than anything we'd ever care to launch normally, and we'll still fly it on a $2 million rocket or whatever it ends up being. It'll take a while, though, for the industry to shift to that. So at first, there'll be years where we're saying the same thing, where any other rocket flying will be like, wouldn't it be cheaper on Starship? And be like, well, probably, but that was not an option when this contract was won. So, yeah. Let's see here. This is from Carson. Says, "Hey Tim, I'm crossing my fingers. You are going to go on Deer Moon. When will you find out if you are going? Also, is your suit going to be orange?" I don't know about the orange suit. That would be awesome. I might have to see if we could get a custom suit that like pays homage to the old suit. That would be awesome if that happened. If we go to deermoon.earth, I don't know. I don't know the answer to this. I just know from this timeline here, it does say that the Step 4 and Step 5, we don't really have dates, but basically the final interview and medical checkup would be by late 2021. So my guess is we will know by June who was chosen. So in the next month or so. Yeah, I don't know. I mean, I have no idea who they'll choose, what things they're looking for in the people going on Deer Moon. I have no idea. I do want to think that I'm not the best I'm not going to even remotely pretend to be the best YouTuber, the best science communicator, or the best artist by even any stretch of the imagination, or the best musician. I'm not any of those things, but I hope that my passion for what I do does count for something, because I genuinely absolutely love what I do. I love the future that we're living in. And it's ironic, the first video I ever really put up on YouTube where I'm standing in front of a camera explaining something was talking about Deer Moon before it was Deer Moon. It was the Falcon Heavy flying people around the moon, released on February 27th, 2017. It was my first video really ever on, like my first YouTube video. That wasn't just like a, restream or something from something I did on Twitch or something like that. So it would be irony coming around, it would be full circle if it just happened that little step of making a little YouTube video ended up being, yeah, that would be nuts. Let's see. This is cool. From Chef Dwayne, says, your father was a World War II pilot, flew the P-51D. That is awesome. I believe that is very, very cool. Presidential unit citation amongst others. That is awesome. Isn't the P-51, that's the Mustang, correct? I went out on a limb there and just threw it out there. Yeah, but I used to love many old school World War II planes so much. So this is from Logan. Are you going to be releasing some new t-shirts t-shirt prints soon. Yes, we're going to have a handful coming out in July. A really cool series that I'm excited about. And we're also going to be releasing a shirt for when we do around, like when we kind of announce the Russia trip. So that one's going to be awesome. That one actually I'm most excited about. That's going to be the coolest shirt you guys have ever seen in the store, I promise. This is from Sam. 8 hours for your space shuttle discovery. Yes. Very, very cool. The Lego set is amazing. You guys will hear more about that in a little bit. This is from David. How's it going, David Willis? All 3 pointy ends looking good today. It was phenomenal. Pointiest of ends, all 3 matching pointy ends. That's something that I like, is that the fairing size is the same as the nose cones on the boosters. All 3 looked great. Very, very flamey ends too. So very pointy and very flamey. Thank you, David, for saying hi. South Armstrong, will Starship utilize centrifugal forces for artificial gravity on the way to Mars? This comes up a lot, that people are like, it needs to have artificial gravity. It's only going to Mars for like 6 months maximum. That's the normal amount of, zero gravity experienced on the ISS. As far as priorities, that's very low. Radiation is a much bigger concern on a trip to Mars than the zero-G aspect. Now, granted, one of the things that would be hard is after 6 months of zero-G, your body is very weak when you experience gravity. So when you land on Mars, the question is, with 38% gravity, do you recover quicker? Because, it's not quite as stressful as on your body. It's not quite as strenuous. Can you just kind of get it, like, will you just be able to stand up and walk, or do you have to have a full day of recouping once your vehicle is safely on the surface of Mars and like just crawling around for the first day inside the cabin before you do anything? We don't really know, but we don't know if there's a direct correlation between the amount of gravity, and same with like bone loss. Like, is 38% gravity mean that your bone loss and your bone density loss is 38% that of Earth? So you experience it 2.5 times faster than you would here on Earth, or it's 2.5 times worse, and it's the moon at 1/6. Is it 6 times worse bone density loss on Earth? And if our opposite end is zero-G is X amount, like, is it linear? Does it is it like 50% gravity is like 99% as good as zero? You know what I mean? Like, so there's a lot of things there. As far as spinning centrifugally, I don't really see that happening anytime soon. It would absolutely potentially be an option with 9 meters. Well, no, it's not actually an option at 9 meters, because 9 meters, you have to have a pretty vast distance to not get sick. So even if you're in a 9-meter wide spacecraft, spinning through the center of it, your head would be experiencing a different speed than your feet, and you'd always feel like you're falling. So your brain and your inner ear will be like, oh, constantly, and you will feel very sick. So the only option to really, with a Starship of this size, the current iteration of Starship, to be able to introduce artificial gravity is to actually tether 2 together and spin them like nose to nose. And of course, someday we might see something like that. I'm not going to say we won't see that, because that's absolutely, there is some potential there. Now, again, is it worth it? Do we need to do that? Is that something we have to focus on to get to Mars? Probably not. That's probably pretty low on the list. But as far as luxury items of going to Mars, yes, sign me up for having some artificial gravity. That's really confusing. How was I seconds faster than the ULA live stream? That doesn't make any sense. Because I was just pulling from their YouTube feed. So, that makes no sense. Maybe you needed a refresh on your end. Thank you so much from Thashara. Says, thanks for always converting Fahrenheit miles to centigrade and kilometers an hour. Keep it up. Love your content. From Sri Lanka. Well, thank you so much. Hang in there. I know you guys are struggling out there a lot right now with COVID. That is some scary stuff. So just hang in there, stay strong, be safe, and stay healthy, my friend. But yeah, I always want to try to convert to the standard, to metric standards, because vast majority of our audience has no idea what like 30 degrees Fahrenheit is and how fast 100 miles an hour is. Whereas most people in the United States have we use a lot more metric than people realize. Like, we're in the US, I think we're more familiar with metric system than the rest of the world is to the English system. And we're the vast minority. We're like 1% of the population uses the English system, or imperial, and everyone else uses metric. So I like to try to, and all of these engineers, they all use metric. All these rocket companies will use metric. SpaceX doesn't allow any imperial anything like in their doors. My friend makes kombucha, or kombucha. I don't know exactly how you pronounce it. And he converted to 100% metric because he wants to be able to easily scale up. Like if they have a milliliter or something, and he wants more of it. He's like, oh, just do simple math as opposed to like, now you had 2 cups there. How many liters in a gallon? You know, like, I don't know. Yeah, so there we go. So Deep Quake, why aren't we spending this kind of money on reducing the existing CO2 in the atmosphere? Well, Elon Musk and Peter, is it Peter Diamandis, with the X Prize program, are raising $100 million if you can solve how to pull CO2 from the atmosphere. So go for it. Like, you can be making money learning how to extract CO2 from the atmosphere. It's one of those, life isn't this or that. You know, it's not like if we didn't launch this rocket today, we would have put that money straight into carbon monoxide or carbon dioxide removal, you know, and carbon removal from that. Like, it just doesn't, life doesn't work that way. If I buy a pizza today, that doesn't mean that I took someone else's pizza, right? It's like, that's just not how the economy and how the world works. There are a lot of gray areas. There's a lot of overlap. And a lot of the reason that we know anything about CO2 and its effect on our planet is because of rockets and because of satellites measuring our atmosphere, measuring the height of the sea, measuring the height and density of trees, measuring so many things that we know about our planet and about other planets as analogs, you know, to be able to compare against how all these effects matter, say on Venus with a runaway greenhouse gas effect, or Mars with virtually no atmosphere. You know, we can study those, and it's because of rockets and spaceflight that we know anything about this. So the answer, I don't think it's as simple as we didn't launch this, therefore we could have done this better. I think it's always an evolution. We need to be doing both things. We need to be continuing to do our things, but working on ways to mitigate and lower our greenhouse gas effect, you know, on Earth. And I think rockets, you know, again, of course, if you type in rocket pollution in your Google search, there's this article on this website called everydayastronaut.com. How much do rockets pollute? And the big reminder here for everyone that ever has questions about how much rockets pollute and what their output is, the biggest takeaway obviously is the final numbers at the end of the video. As far as comparing it to the airline industry, here's how much the airline industry emits for CO2, and here's how much the spaceflight industry emitted in the same year. So, and the airline industry is a tiny fraction of all CO2. So what it comes down to is even currently commercial airline industry, all airplanes, commercial airplanes only are 2.4% of global CO2 emissions. They're not even a big, as far as fish to fry, don't worry about even the airline industry hardly. Focus on other things like road transportation and industry, heavy industry. Focus on that first. Then, you know, maybe focus on, there's a lot bigger fish to fry than even the airline industry. That being said, rockets, current CO2 output is 0.0000059%. So if we're worried about CO2 emissions, focusing on something as sparse and as uncommon as rocket travel is definitely not the right place to start, in my opinion, not the correct thing to focus on. Let's focus on the biggest fish to fry, where you have the most gains you can make, where you can, you know, if we have finite finances and finite resources, let's focus on the ones that we can make the biggest change with the least impact on our economy, with the least impact on society, where we can see growth in jobs and things like that. So transferring some of the old school ways of producing energy, train these people into new jobs that can produce clean energy. There's a lot of other options to reducing CO2 if you're worried about it compared to just like being like, well, we shouldn't launch rockets anymore because they pollute. Yeah, that's my question. That's my answer to that. Yeah, if you have more questions about that, watch that video. I did a lot of research on that video. I'm quite passionate about that because it is something that people talk about all the time. I know that wasn't your direct question, but I hope that I still helped answer it. Well, thank you very much, Tyler. This is from Bruxus. May I request a video on post-launch booster crash splashdown cleanup? Something I've never heard anything about. That was actually supposed to be part 2 of this video about how much rockets pollute. Is what's their pollution like on the ground? How much, you know, what are we putting in the oceans? What's that impact? How much does, you know, but the truth is the first video did horribly. It did really bad. For the effort to YouTube watch ratio, it did horribly. So I'm not honestly that motivated to make the follow-ups to these videos. I just have so many other videos that I want to work on. So that is something I would love it. So I'd love to do someday. Infinity Shroud says the space shuttle wasn't fully clear. It had a purplish glow to it. In the cone of the water vapor, at some point, yes. In the mock diamond and a little bit of it, because water obviously will have a little bit different spectral effect on light compared to just what we're used to. So that's why the sky is blue. So it's a similar phenomenon there. But for the most part, I mean, it was quite literally transparent because it was, it's water vapor. Thank you very much, Ethan. Let's see. This is from David Willis. Willis says, this is the Delta IV Heavy's final flight as the largest operational rocket. Its next launch won't be until 2022. And by then, SLS and Starship will have flown. You're absolutely right. I mean, this is barring some major setback in either program or both programs. This may have been the last time in history that the Delta IV Heavy carried the title as the largest operational rocket. So yeah. SLS will be king. Well, it depends on SLS, which will launch first, orbital, SLS versus Starship. I mean, anyone's bet at this point. It's hard to tell with Starship because it's just going on you can plot the course of SLS very, very, very easily. It's very predictable. You can plot its chart. There's published dates. There's milestones that are like written in stone with NASA and the companies building the SLS. It's a lot more written in stone. Starship on the other hand is like, we hear really, really, really aggressive timelines on the rocket. I think it was at the end of 2019, Elon said Starship would be orbital in 6 months. At the beginning of this year, they were saying in July, they're hoping to have it orbital. I still don't quite buy July orbital, just seeing how much more has to be done with the pad and the infrastructure. And with the rocket itself, obviously we have to have a successful landing and then see SN20 and the booster and all the things. I don't see it going orbital in July, but this year still might not be out of the question. I don't know. It's anybody's guess at this point. Mr. Muskrat says, can the engine nozzle type, ablative, regeneratively cooled, etc., have an effect on ISP, so the specific impulse? I think it does. I think it can. Someone needs to double check. I don't exactly know how or why, because you are ejecting mass, so it does affect the ISP. But I can't think if it's an improvement or you're dropping mass, so you're lightening up the rocket a little more. I know that's not a direct correlation to the ISP, but overall efficiency of the rocket, but. That's a good question. That's a little bit beyond my pay grade, and I'll happily admit that I don't exactly know the answer, but maybe that's something I'll try to ask around about. Musical Wolves, how many pounds of propellant is needed for engine chill for Starship? That's a great question too. It's beyond my pay grade. I don't have the exact answers for that, but they likely, they flow it pretty, there's a decent amount of flow going through the turbo pumps and the walls of the nozzle and everything when they're doing an engine chill down. How much? I'm unfortunately can't say. Now, likely with it being liquid oxygen, the cool thing is they can just pump it out and they can continue to back pressure and keep filling up the tanks on the ground. So while it's connected to umbilicals, you'll oftentimes see them topping off liquid oxygen right up until T-1 minute. So those prior 10 or 15 minutes of engine chill are usually done while it's attached to the ground system. So then it just turns into gaseous oxygen. We can reclaim it later, no big deal. Okay, so let's see. This is interesting. Dami says, can Orion technically launch on Starship if SLS isn't ready and the belly flop is unsafe? I mean, again, when you're making decisions about what vehicles fly and, what rockets launch what vehicles and things like that, there isn't just you don't just copy and paste. It's not Kerbal Space Program. You can't just say like, oh, pop it on there, no big deal. There are a lot of considerations when building a launch infrastructure. Even like, how tall is the tower, right? If you build this ground system and how do you get crew onto the tower? We've already spent over $1 billion on one of the mobile launch towers. I don't want to spend another $1 billion trying to build a slightly different height tower because now we have a different place for the crew to get on when it's attached to a different height rocket and all these other considerations. I mean, it's just not really an option. SLS will fly. It will launch Orion. That's set in stone. How many times? That's maybe more up for debate. Will it be? I think the question in my head is less than 8 or more than 8 times. That's my truth. I think that's kind of the reality of it. That's kind of my number is about 8. But I'll also be shocked if it doesn't fly 3 times. I'll be shocked because there's hardware out there for 3. So yeah, I just don't think we'd see that. I think NASA would totally pivot if something is not if there's something completely flawed with the Orion and SLS system. I think we'll see NASA massively pivot personally. Tucker M says, as much as I love SpaceX, I realize expendable launch vehicles still have a purpose in space exploration. I believe that's a key to how we'll make human life multiplanetary. Go Delta IV Heavy. Well, Tucker, I really appreciate that sentiment. But I do personally believe the future of spaceflight and the future of how the industry is moving is into cheaper and reusable launch vehicles. I think that's a trend that will just continue to grow. I don't see it going back in the opposite direction. It's a shame that the space shuttle didn't live up to its full promises because I think it left such a bad taste in its mouth from, because it's an incredible vehicle. Like, let's not kid ourselves. The space shuttle was amazing, but it didn't quite do everything it was supposed to do in the timely manner and as much as it was supposed to cost and everything. And I wish that it had done better or that they had evolved it to do better and live up to those promises more. But I don't think that expendable launch vehicles really have much place in the future. In 15 years, I'll be shocked if there's fully expendable launch vehicles. I think there'll be at least 10 more years of expendable launch vehicles in existence, but I don't think by 2035, 2040, I just don't think there'll be any expendable launch vehicles. But I think they're, reliability, like there's a lot of reasons to still be using them now because the development cost and the risk of trying to rely on a fully reusable vehicle is still quite high. So until that is done, yeah. Thank you very much, Martin. Let's see, this is from Jaswinder. Hey, Tim, what if you just create just one new channel for live streams only, like Everyday Astronaut Live, something like this, and channel for main videos only? I just don't see the point of breaking them up personally. All you're doing then is diverse, like you're splitting your audience, and it just feels like I don't do enough on the main Everyday Astronaut channel, already as is. I want to do a lot more on this channel. Life has been nuts this year so far. I want to be able to focus more and more on making content. And I feel like just splitting channels, all it's doing is lessening each channel's impact. So, yeah, that's kind of why. From Martin says, would there be a benefit if side boosters had extra fuel and pumped into the main booster at a late stage, more fuel after separation? Yes. So fuel crossfeed is actually advantageous because you can run basically all the engines at a higher throttle setting, minimize gravity drag, and there's some benefits there to actually dumping your side boosters slightly earlier and having a fully fueled center stage. You'll actually gain a decent amount of delta V. You'll gain a decent amount of extra performance, but there's a lot of extra complexity in doing that. Like that's not a simple thing. So yeah, good question though. Silent, why is the Delta IV Heavy rocket obsolete so expensive, and what makes Vulcan cheaper? So one of the things is, it's 3 cores, so you have a lot more rocket to build. The RS-68 is an engine there's only one of them per core, so they just don't make a lot of RS-68s. There's no reason to make them cheap. There's not a big enough scale of production to make a cheaper engine. They're large. That engine attaches to a 5-meter. It's a large engine. It's a really, really big engine, and I think people forget how big and expensive that is. Now, Vulcan will only be using 2 main engines. It'll be using the BE-4, which is going to be a more mass-produced engine, of course, produced by Blue Origin. So assuming that it lives up to its goal, having cheaper, those engines will be a lot cheaper than the RS-68A. Will be using a lot cheaper fuel. Methane is substantially cheaper than using liquid hydrogen. So right there is another big step in the right direction. They're commonizing a lot of their parts in manufacturing, so that'll make the rocket cheaper too. And hopefully just by increasing their launch rate, I think Vulcan's going to be able to compete with the Falcon 9 almost on some missions and some performance metrics for price, because they're hoping to get it down to be that cheap. Now the thing is, the RL-10 upper stage engine, there will be 2 on Vulcan most of the time, right? Or is it just 1? Up to 2 is really expensive too. Really, really expensive. But they are making steps to make that cheaper. But yeah. South Armstrong, we talked about that earlier. Sorry, went into it pretty deep. But thank you for the question. Hopefully you caught that answer. From Mattis, if Starship full stack becomes operational reliable, why would NASA go through the trouble putting a Starship lunar lander on top of SLS? No, it's not ever going to go on. You need to watch my video. Just type in on Google Artemis versus Apollo. And hopefully one of the first things you'll see, everydayastronaut.com, Artemis versus Apollo. I also, of course, have a video version of this as well. Definitely watch this video, because we explain that the lunar lander flies completely separately. The lunar lander will launch on Super Heavy, and it will meet it out there in lunar orbit. So this video was a year old, but it actually lives up to, the only thing we didn't know is which lunar lander they're going to choose, but we went through kind of most of the options on how to get it out there, how they're going to meet in what's called near rectilinear halo orbit. We kind of go over the capabilities of the SLS versus the Saturn V, the missions, and how they actually look. So it's definitely worth, check this article out. You'll actually learn quite a bit about how Starship will fit into the Artemis program, how it fits alongside the SLS rocket. And yeah, hopefully it answers your questions. So yeah, thank you very much, Gadget Merc. This is always confusing to me, Mookie Machine. So as you saw in the countdown, they'll just hold 4 minutes on the clock, and they'll continue doing things and do this poll and all that stuff. And then the last 4 minutes are the part that is fully automated. So that's all that's automated in their countdown. The rest of it is not. So because of that, they want some basically wiggle room for human error and be like, all right, how's everything going? Bob, are you good over there? Yep, we're looking good here. Kind of doing things manual with it leading up to the certain point. So at about T-minus 6 minutes, they'll close out the go, no-go poll. And then at T-minus 4 minutes is when they go into the final terminal count of the rocket. The rocket has taken over the rest of the countdown and the rest of the whole system. So at that point, they can officially set the clock to be T-minus 4, but it is kind of confusing. Let's see. Joe, is using ozone as an oxidizer too crazy for even Elon? I'd love to see a video on the crazy potential fuels oxidizer, like the tri-fuels you mentioned. That'd be a good idea, actually. Like, what is the... Yeah. I don't know about using ozone as an oxidizer. I don't know. Yeah. Good question. Maybe that'll find its way into a video in the future. Space Enthusiast wants to know, is there a plan, or are there plans for a ULA reusable rocket? Yes, the Vulcan, this middle one here, you can kind of tell it's like the love child between a Delta IV and a Atlas V, does have plans for engine reusability. They are planning to drop the engines off of the booster and then recover them and swoop them up out of the air with a helicopter, kind of like how Rocket Lab's going to be catching their Electron rocket with a helicopter. And also their upper stage is actually designed to do kind of like what Starship's doing, where it's going to meet up with another upper stage, transfer all the fuel over, and they can actually refill the upper stage, and hopefully be able to reuse those upper stages in orbit, which is key, because getting them to orbit's the hard part. Once they're in orbit, you have a lot of potential to do a lot more performance. So, Chris, Scorpio Trader Class Fund, thank you. My dreams will come true someday. Yeah. So Abraham wants to know if there's any concerns for boaters on Crew-1 splashdown. I think they'll have it figured out this time. I don't think they understood the implication of landing that close to shore last time. I think they'll have it taken care of this time. Cameron, why bring Moxie to Mars? Just simulate Mars CO2 here. You can run simulations all you want. You can simulate the whole rocket launch. We can simulate living on the moon. Why ever go to the moon? There's nothing like doing it on the actual planet or in the real environment that it's going to be in. Simulations are great. Obviously, Starship has had simulations so far, SN 8 through 11, of how it's supposed to work. Hasn't worked yet, so there's nothing like actually flying it and using it. Same thing for Moxie. Moxie's best used, and you can only really test it out and prove it out on the surface of Mars, because you just never know. All right, let's see. Will we see a fuel depot in Leo, and will they get rid of helium? So I'm kind of anti-fuel depot for the most part, because the smartest thing to do, a fuel depot is just literally you're paying the mass penalty of having the skin up there already. The other option is you have your rocket that you want to be fueled, be up in orbit, and then you fuel it up. And that way you're never just left with just the mass of the dry mass of your fuel depot. If you're launching up and then filling it up anyway, why aren't you filling up just the ship that you want to go somewhere further? If you need that capability, instead, all you're doing is you're just letting it sit up there, boil off, and you have the dead mass of this fuel depot. So you might as well just go straight to refueling up your upper stage. So, Armand wants to know in Discord, how are they going to be refueling the Starship Moonlander? Will they just fly Starship tankers to the moon? Now that I don't actually know. They likely will be. I don't know if they're going to be refueling it in an elliptical orbit, or if they're sending tankers up to near rectilinear halo orbit or to orbit around the moon. I don't actually know. That's a really good question, and I think we'll have to learn more about it. I'm going to wrap this up because I do actually want to catch the SN15 static fire. So, Josh, do you have a remote live feed for when you're not in Texas? SN15 ground venting as of right now. Nope, we don't do that. We're not doing that. We still set it up each time. I will be covering SN15 when it does launch, though, I promise. But not static fires. I don't really do that. Matt Horkin, do you worry that SpaceX's market domination will turn it into a bloated monster like ULA has been? I think it'd be ignorant to claim that Boeing don't have a history of radical aerospace development. That's a loaded question there, Matt. There's always room for competition. SpaceX might dominate for a while, but if they rest on their laurels too much and get too greedy about it, there will be other competitors that will come out and knock them off their high horse. Similar to how, kind of like ULA and Boeing have had kind of space dominance for the last, 20 years for the commercial market in the U.S., and now they're kind of getting kicked off of that high horse a little bit. So, that's a risk, but that's what the open market is for. Brian Clausen, hey Tim, rocking out, waiting for the ULA launch. Your last SpaceX belly flop video was great. Keep up the great work. Thank you, Brian. Thank you for saying hi. Always good to hear from you. Thank you so much. Max, just caught up on the stream after the launch. Wow, those arms really yeeted away. Thanks for the awesome coverage. Well, thank you so much for watching with me, Max. Go for Launch 13. Why is SpaceX already testing SN15 before SN12? They scrapped 12, 13, and 14. They didn't have a ton of hardware for them. They were obsolete hardware, though. They were already moving on. By SN8, once SN8 launched, they were already like, we got to make some changes. A lot of the changes from 8 and 9 we're seeing in SN15. So they started making hardware changes. They were building them before they were ready to test them, basically. And we knew this is a problem when you're building them that quickly. At some point, you're getting so far ahead of yourself where you might have to make changes. So the vehicles that you build, if you get too far out before you test these new ideas and have new problems crop up, you're just testing obsolete hardware, which is pointless. So that's what they're doing. They're going from 11 to 15. Nope, Thomas, no views. I'm going to sign off here so I can watch myself on some other channels. David Willis, while we're on the topic of SLS, it just passed Miami. It's getting really close to the KSC. That is very cool. I can't wait to see that baby get into the vehicle assembly building, start stacking. I hope I can get some footage of it someday. NSS, nope, no static fire views, guys. Not here. Gadget, thank you so much. And from Matisse, what was your, of course they fly separate. What was that about, though? About SLS carrying Starship. Yeah, totally separate. Guys, I got all caught up. Thank you so much for all your awesome questions, and thank you so much for your support. That's going to do it for me. I'll see you guys next time, hopefully for SN15. I'm working on some other stuff in the background, so maybe I'll have no, I don't want to promise a video anytime soon, because you know how life works. I'm going to hop off, though, so I can probably pull up our friends at NASA Space Flight or Lab Padre to check out if the static fire goes well of NS15. But that is going to do it for me. I'm Tim Dodd, the Everyday Astronaut, bringing space down to Earth for everyday people. Goodbye, everybody.